All right, so what I've got here, if you want to move your book out of the way there. Okay, this is a ballistic pendulum. By the way, I believe I can, now that YouTube is done censoring me, I believe I will upload this on the physics guide. So if you want to watch this again, go there. So I think I'm off of lockdown thanks to the censorship, and just they're just so nice. Okay, so what we've got here is the way they used to do, like they wanted to find the velocity of a bullet. They use really what's called a ballistic pendulum. So here's your bullet. You want to hold this still?
Oh, yeah.
Yeah, thanks. I had to Earl that dude a little bit, looking a little rusty here. And what they would do is fire it into a block. And on this side, let me just turn it here. And on this side, you see there's markings there, right?
Yeah.
And what you would do is they would shoot a bullet into a block and measure how high it went. So let's make sure, let's get this still. Pull the trigger, all right. And then what you do is you measure the vertical height, because what we do is this. We determine this combination, notice what I'm saying, we find the kinetic energy of this, or I'm sorry, potential. We know the mass of this, we know gravity, and we know the height it went. And so we back the truck up, so we compare what? The kinetic energy of this turns into potential there. So we're going to try this again. You have to hold it again for me, because just hold that, Anders. Thank you. We'll try it one more time. One more time. 3, 2, 1. All right. So what we have here is a ballistic pendulum. So once we found out the potential energy of this is again how, again, a long, long time ago, all right, that's how, well, I won't say a long time ago, that's how they determined, well, they backed the truck up and they found the kinetic energy, they knew the mass of the bullet, so they tried to find the velocity of the bullet, okay? Now, the cool part is we have modern technology, so now what they have is it's set on a tripod and has 2 loops, a loop here, a loop there. You shoot the bullet between the loops, okay? It knows, okay, the distance it knows between the 2 loops, and it measures the time that it entered the first loop and exited the second loop, or exited the whole thing, entered the first loop. So if you know the distance between the 2 and you know the time, what can you find? Velocity or speed, okay? And guess what? I have one of those. So it's pretty cool, because what I have to do is I set it up on my tripod in my backyard. All right, I set it right there, whether it's my AR-15, one of my AR-15s, all right?
Ooh,
yeah, just one. And because I also, as a reloader, I like to load, like if I load like higher or lower powders, I like to get a certain velocity. Like to me, the sweet spot for an AR-15 is 3,000 feet per second. So what I would do is I'd find the sweet spot for my ARs. So what, we're not supposed to talk about that, are we? Okay.
That's another strike.
We should call that
Water gun.
Water gun, yeah. We'll use cryptic language. My COVID gun. Oh, better not say that either. Okay.
That's another one.
All right, so
You literally just got
I'm gonna get in trouble again. So the thing about it is I would load a certain powder, like, and I can tell you right now in my book, it's 24, I would start at 24 grains for 5 bullets. And I'd go out there, bang, 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 bang. 5 shots. Bang, 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 bang. Oh, 5 shots. And then I'd get an average. So I was getting around 2,800 feet per second. So instead of 24 grains, I slowly went up. 24.2, 24.4, 24.6, 24.8, and 24.8 of this specific gunpowder would give me 3,000 feet per second. Or it'd go a mile in 2 seconds. 1,000, 2, 1,000. We're past a mile. Okay, so the sweet spot for my artillery, okay, is basically 3,000 feet per second. That's me. And that was right. That's usually where the store bought is and whatnot. I haven't bought store bought. I make my own ammunition, so I haven't bought store bought ammunition in like years. Mine's better. Okay, my AR-15 stuff is better. So bought a new gun the other day. What I do, went out and shot reloads, my ammunition. So a lot cheaper, cheaper. Everybody says, "Oh, Miss," yeah, I used to actually. I taught. I know, I was going somewhere with this, but totally forgot. Oh, yeah, I taught a reloading class. I taught like several gun classes, AR-15 classes, but another one I taught was the reload classes was pretty regular. I made good money off the reload classes. But long story short, people say, well, but you know your AR-15 round, that, you know, I would say, well, how much does it cost me? It cost me 23 cents to make from beginning to end. And they would like, well, you can buy it for 28 cents, so I don't need to take your class. Well, what had happened was, I'm like, well, I'd make them at 23 cents. True, you could buy them at the store for 28 cents, okay? And so what happened? Well, the last couple of years, COVID happened and everything got shut down. Factories got shut down. So then it got up to be $1 a round, okay? And I always tell people, I said, you don't wait till you, to get the knowledge like when it's an emergency. You learn and get the knowledge now. And so like today, there's hard to find components, but I have all the components and I'm making ammunition much cheaper than what is bought at the store. So don't ever wait till the last minute on that. All right, so I went way out of the way on that one. Okay, so hang with me here. You walking out? Did I offend you?
No, I was just sitting.
Oh, okay. Yeah. Okay, so this is what we want to do, is we want to convert, all right, we want to find what is the velocity of this situation, all right? So what I want you to catch is this. I can tell you there's going to be one on the exam. And probably a third of you are going to miss it. So, but I'm giving you a heads up. I don't know what else I can do. Okay. So one of the things we have is this. All right. We have a kinetic energy being converted into potential energy. So watch this. So, and we also have conservation of momentum. So here's what I know. We know kinetic energy is being converted into potential energy. So here's what I need. Oh, by the way, I need to convert this to kilograms. So is that 0.0? Kilograms. All right. So here's what I know. I need to know the kinetic energy of the block bullet combo is being fully converted into potential energy at the bullet block combo. So what it's going to look like is this. 1/2 times 2.0025 V squared, this is I'm going to write combo, is equal to, actually it's the same mass, and the height was 0.85. Now guess what, I want you to find combo. So find what the velocity of the combo is here. And that's not what we're looking for. Okay, what'd you get for the velocity of the combo? but not high, actually. What'd you guys get?
4.1.
What is it?
4.1.
You make it
meters per
4.1? Okay, y'all square rooted it, right?
Yeah.
Okay, so 4.1 meters per second. You understand, that's a block bullet combo. But what I want to know is, what's the velocity of the bullet? Well, I will say this. I'm going to give you a hint here that I've never given a hint. Number one, whenever you have a ballistic pendulum problem, you are going to have to apply kinetic potential, energy, conservation of energy. You're also going to have to apply conservation of momentum. Here's why. Well, that's not what I'm looking for. But I do know what? The momentum, the bullet locks into the block. What type of collision is that?
Elastic.
Huh?
Elastic.
Non-elastic.
Inelastic. Elastic means it's bouncing off. All right? So what I'm going to do is this. Mass of the bullet, 0.0025, times the velocity of the bullet, plus what? The block is 2 times 0 is equal to what? Oh, here we go. 2.0025 times velocity of the combo. So basically, I take this, plug that in here. What's the velocity of my bullet? What's the velocity of my bullet? Probably the bullet's a little bit powerful here, more than because I made the problem up, so. I got the gut feeling it's gonna be big, quite big. What?
8.2 meters per second.
Really?
I
Well,
got,
that's not very big, that's like my dart gun.
I got 3,241.
3,000, anybody get 3,000? I need to get a confirmation.
Yeah.
Dave, you got 3,000? Okay, so the velocity of the bullet is what? 3,000 what?
Meters per second.
Oh, just 3,000? Is that what you guys are saying, 3,000?
If you round it.
Well, what is it unrounded?
I got 3,269.4.
3,200 and what?
69.4 meters per second.
Now that's kind of a little, that's 9,000. AR-15 is a third that, would be 1,000. So, I mean, we kind of overshot it there when I made it up, okay? And you will have some on the homework, you're gonna have some on the test. You'll have one on the test. Yeah.
I don't know why. It's not like super off, but it's a decent amount off. I got 3,284.
Oh, yeah, no, you're good. You're
Okay,
good.
I just didn't know
You're
why
good.
it would be-
Oh, no. Now, when you're starting to deal with like very large numbers here and small numbers here, yeah, you're cool.
Okay.
You're good. Yep, that's just a rounding issue, okay? Do you guys have any questions? All right, that's the ballistic pendulum. So here's what I'm going to give you. Listen. The handouts. I'm going to go ahead. I got a lot of stuff to cover, but I'm going to try to do just one thing per day. I'm going to do one thing per day. Take one and pass it. Take one and pass it. Now here's the thing about it is, you may want to jump. I won't add any of the book work yet to you, any more book work, but you may want to start and do some problems on here. I can tell you, let me tell you what you can do right now. You may want to bounce around here, but you may want to just put like a little small mark under like your number here. 1 you can do, 2 you can do, 3, 4, 4 is the ballistic pendulum. All right. 5 and 6 we're going to deal with on Monday, those type of problems. 7, Monday. 8 is just a momentum impulse, you can do that one. 9 and 10, I think you can handle. So I'll let you, I just kind of started, the ball rolling, so you can kind of hit and miss on that, okay? So go ahead and get busy. I'm gonna upload stuff here, so work on that. Our test is intended for next Thursday. I don't know about that, that's the goal. We'll see, okay?